All right. Question 8. So this is what's called an arithmetic sequence. Yeah, I'm here. Uh, so what an arithmetic sequence is that it's a linear equation. So like this thing down here, it says a of n. A of n really means y. Okay, that means y. And then there's a space here, and that space it wants slope. The n is x. And then the plus part is, well, y-intercept. So it basically wants you to figure out, based on this information, what's going on. Now, what it is that the little subscripts, like you see little 1, little 2, little 3, little 4, those are x values. Like that, think of that as like those are the x values because that is what part of the sequence it is. Like this is the first part, the second part, third part, fourth part, fifth part. Those are x values. What they equal are y. Like this is what happens in the first part. Here's what happens in the second, third, fourth, fifth. So we can let's do slope. Okay, so if we do slope let's use the first two. That'd be 33 minus 47. And then 2 minus 1. Okay, the 2 and the 1 come from that being the part of the sequence. You can do that, you're going to get negative 16. So that's why isn't that there? Oh, crap. Not negative 16. I can't count today. It's negative 14. Ugh, I can't subtract today. All right, negative 14 as that. Okay. Now, we can do a whole bunch of point slope form and all kinds of other things to get to the y-intercept. But an easier thing to do is that since here's 2, here's 1, that means imagine there would be like an A0. A0 would be just to the left of this. And since we are subtracting 14 every way, look, the 33 minus 14, 19, 19 minus 14, 5, and so on. If you go in the opposite direction, you'd actually be like adding 14, like 33 plus 14, 47. So if I were to do 47 plus 14, I get 61. Yeah, that's what that is. All right, what is the range of that? Okay, so I recommend actually like graphing that, and you can kind of see the range. Let me show you what I mean by that. So there is some algebra ways of explaining this, but I recommend just putting this into the calculator you're given, and you can kind of see. Where is it? Holy crap, that is way up there. So right here, if you actually kind of look, this number right there is an important number to really understand what's going on. So once range. Range means y value. So the y value here is 900. Now, this is the absolute top of the parabola. Like you actually graph this, it looks like this. It's huge. But we just need this number. And this number basically means that y is every value below 900. See, like y can be 800 something, but y can't be 1,000, right? So there's no red graph up here. There is every red graph is right below it. Now that is the reason why the answer is this one. All real numbers that are less than or equal to 900, meaning this is, if you look, the graph is up there. Like y is every value below 900 or 900 itself. Okay, next question. All right, a counselor asked college students who had jobs how many hours they worked each week. The counselor then compared the number of hours each student worked and the student's overall grade average. The table shows the data. Okay, there's a bunch of data. Based on the correlation coefficient for the data, what type of linear association exists between hours worked and overall grade average? Okay, so this is a strange way of doing a scatter plot question or like a linear regression question. The most accurate way to do this is do a regression analysis. And since it says linear, that allows me to kind of do it pretty quickly. So it's kind of the most accurate way to tell what's going on. So strong negative, weak negative. Okay, so basically the positive ones that mean if I were to like make plot this, it'll show a line going up. The negative ones mean the line would look going down. The strong and weak has to do with like how close the points are to the line. So I'm gonna go to Desmos and kind of do that. So okay, so here I'm in Desmos. I press the plus sign because I'm gonna make a table. I'm gonna make a table that mimics exactly what's in these. So and you get to do this on the STAAR exam too. Like it allows you to do this. Okay, so now have a table of exactly those forms. And now I'm going to put in the linear regression formula, which I hope some of you remember. And so similar mx1 plus b. Okay, so I gotta change okay, so all right, so the blue line is what happens after I wrote this, okay? All these dots that we see here are these coordinates that I just put in this table, okay? So if we look at the line, is the line going up or down? It's going down, so it's negative. And I would say it's strong negative. I would say it's strong negative because these dots are all pretty close to the line. Like they're all very close. Like if these points were like all over the place, like really widely, very, very far away, I would not say, I would say it's weak. Like if these were like, these dots were like super far away, but they're all pretty close. They are. So I would say strong negative. Yeah, that's what I would say. All right. Which statement about the graph of that is not true? Okay, so we have a y-intercept of 16. That's what that is, so it's not A. 0.5 means we're decreasing by 50%, actually. The graph is decreasing for all values of x. That is actually true. That's true. All right, so the correct answer, all right, the graph has a horizontal asymptote at y equals 0. That is actually true. That means it never actually crosses the x-axis. Now, if it never crosses the x-axis, that would mean it doesn't have an x-intercept. If you were to actually plug this into Desmos, you'll see that it never actually crosses the x-axis. It'll look like it gets really, really close to it, like almost on top of it, but it never really crosses the x-axis. So it does not have an x-intercept, and that's why that is the answer. Yeah, again, I would just graph this in Desmos and see what it looks like, and you can kind of tell, really. Okay, what is the solution set that best represents the inequality y is greater than or equal to half x minus 2? Graph the solution set of the linear equality in the coordinate plane. First, click the graph button. Okay, so since this says greater than or equal to, I want it solid. There's solid and dashed. Dashed would be like if it just said greater than, like there's no little line below it. To graph the line, select 2 points in the coordinate plane. Well, first up, I know one of them is -2, so I would actually go, bam, -2. The reason why I know it's -2 is because that says -2. Next up, well, okay, so half makes it a little weird. So if I pick a value that would actually work, let's try 2. Half times 2 is 1. 1 minus 2 is -1. So that means it would have a coordinate of 2, -1. And then as soon as I put 2 coordinates there, it makes a line. Okay, then select the solution set. So solution set means, am I shading the top of it or am I shading the bottom of it? So since it says greater than means top. If it said less than, it would be bottom. So it says greater than, that's the answer. Okay, that's actually what the answer is. Okay, let's see, next up. Linear systems. 2 customers purchase coffee and donuts at a coffee shop. Each cup of coffee costs the same amount, and each donut costs the same amount. First customer paid $4.90 for a cup of coffee and 2 donuts. The second customer paid $8.60 for 2 cups of coffee and 3 donuts. What is the cost of 1 coffee? All right, so this is a challenging linear system problem, meaning there are 2 different variables we have to work with. we have to eliminate one of the variables and then solve for the other one. This is a challenging thing I taught you all around like Thanksgiving. So I try to review it this time, but it's going to be tough. All right, so I'm going to translate what it says here. What matters is the bullet points. Up here doesn't really help much. All right, I'm going to say cups are X and donuts are Y. Okay, so that means 490, which I'm going to just write 4.9, is equal to, it says 1 cup of coffee. So I can write 1X, or I'm just going to write X, because that means 1X. And 2 donuts means 2Y. So now it's 4.9 equals X plus 2Y. That's me converting that one. Second customer paid $8.60, so that is 8.6 is 2X and 3Y. All right. Now I have to solve for a cup of coffee. I have to solve for X. All right. That's actually pretty dang challenging in that, like, it's really easy to eliminate X in these equations, but I don't want to eliminate X. I want to eliminate Y. I want to make Y disappear. But I think getting rid of X would actually be easier. Dang, this is a challenging one. I think I'm going to have to explain it in Desmos. It's a little bit easier for me to do it that way. Okay, so what I would do is, there's a couple ways we can do this. There's actually many ways we can do this. I'm just going to eliminate X first. So what I mean is I'm going to make the top one say X equals. So if I make the top one say X equals, that becomes 4.9 minus 2Y equals X. Great. So now that I know that X equals this stuff, I would replace the X in the second equation with what it equals. 8.6 now equals 2 times 4.9 minus 2Y plus 3Y. Okay, so now that is 8.6 equals 9.8 minus 4Y plus 3Y. Okay, if I subtract 9.8 from both sides, I get negative 1.2. And then that would then equal negative 4 plus 3 is negative Y, and that means Y is 1.2. Okay, now that I know Y is 1.2, I can plug in that into the original equation up here. 4.9 equals X plus 2 times 1.2. All right, so running out. So let's just kind of get rid of this stuff so I can go up here. All right, so 4.9 equals X plus 2.4. If I were to subtract 2.4 from both sides, I get 2.5 is X. And that brings us to the answer that 1 cup of coffee costs $2.50. That's hard. I mean, there's other ways that I could do that. I would say that's almost the easiest way to do it, sadly. Like, I wish there was an easier way I could explain it. But, I mean, in regular Desmos, we could have just, like, you could actually just graph them both, and you'll notice where the intersection is, but that's a little bit harder. No, that's actually a bit easier. You could do that, but I'm running out of time with this section, so let's move on to the next question. Okay, I'll quickly do this. So let's see. We have a graph linear function shown below. Here's the graph. Which function best represents the graph? All right, well, first up, y-intercept is -5. That means the answer choice definitely says minus -5. Is it this one? Is it A or C? So is it a is it -3/5 or is it -5/3? One way to kind of do that is notice it says -5 here and it says 3 here. You see how that's a y value is -5 and 3 is a x value? Well, how does slope work? It is y over x. It's y over x. And also you can like imagine they're drawing a right triangle like so. The right triangle would be 5 down, 3 across, and that would also create the slope of -5/3. Okay. All right. I think that's about as far as I can go. These videos have to be 15 minutes. So yeah. All right.